Welcome to day 6 of our explainer. Today, we're tackling an absolutely crucial part of agent architecture. We are going to establish the exact boundary between a model's thoughts and its actual real-world actions. By the end of this, you'll understand exactly how language models interact with outside systems.
So think about this for a second. When you ask an AI for the current weather in San Francisco, how does it actually check it? It's really tempting to picture the AI just reaching out, seamlessly surfing the web to find your answer, right?
Well, actually, scratch that because that is a complete illusion. In reality, large language models are entirely isolated. They are sitting inside a box strictly restricted to their static training data. They literally have no native internet connection, no hands to interact with the real world. It's really just math predicting the next token. So, to give them those hands, we use something called tool calling, which you might also hear referred to as function calling. This is the critical bridge. It is exactly what connects a model's abstract reasoning capabilities to a real-world deterministic action.
To really visualize this, think of the AI as a brilliant strategist who is locked inside a windowless room. They can't see outside at all, but they know exactly what needs to be done. So, to affect the world, they write down a highly structured request on a piece of paper, slide it under the door, and wait. Then someone on the outside picks up that paper, actually performs the task, and slides the result back under the door. In our software architecture, that piece of paper is a structured JSON request. The AI never actually touches the outside world itself. And there's a saying you'll hear a lot in production environments: the reasoning layer gets all the glory, but the tool layer is where the outages actually happen. As practitioners, we absolutely have to prioritize this concept. Most agent failures aren't actually due to flawed logic. They happen because the model called the wrong tool, hallucinated a parameter, or just hit an unhandled error. This brings us to a very strict architectural boundary. You see, the AI model is a non-deterministic reasoner. It merely proposes actions. Your application code, on the other hand, is the deterministic executor. Your code is what actually fires the APIs, touches the database, and validates the math. If you blur this line, you are absolutely going to see silent failures at scale. Let's break down the actual execution loop. It happens in 4 highly predictable technical steps. First, the model hits a knowledge gap and realizes it needs a tool. Second, it selects one and spits out a JSON payload containing the function name and its arguments. Third, your system catches that payload, validates it, and runs the external API. And finally, your system takes that API result, formats it, and hands it right back to the model as fresh context so it can finish its response. Now, because the model is essentially flying blind here, your tool definitions have to be ironclad contracts. Vague descriptions just lead to the wrong tool choices. You need highly precise purpose statements. You need tightly typed parameters. Always prefer strict constraints over open strings. I mean, if you give the model a free text field for a date, it might just write the word tomorrow instead of a proper timestamp. If the output schema isn't crystal clear, the model is just going to guess what the data means. And you know what? This strictness applies to errors too. In the real world, APIs time out, rate limits get maxed. When that happens, don't just crash the system. You want to return a typed, interpretable error signal right back to the model. Think about it. If a tool returns a rate limit reached, retry in 5 minutes error, the AI can actually read that, reason about it, and pivot its plan intelligently. Giving the AI something to reason from is a total game changer. As your agents scale up, you're going to have to choose how to execute these tools. Sequential execution, where tools with dependent outputs run one after the other, is your safe default. But if tools are independent, running them one by one is just painfully slow. Parallel execution fixes that latency, but it introduces a new headache, which is managing shared infrastructure constraints. Things like connection pools and token limits can get slammed all at once.
Let's look at how this plays out in the real world. In practice, tool calling is literally the magic that turns a passive chatbot into an active generative AI system. It is exactly how models pull live information retrieval from your internal databases. It's how they write and execute Python code to solve complex math problems. It's what allows an agent to actually go into your CRM and automate a process by updating a customer record on the fly.
But giving an AI hands means you have to design for security. The blast radius of an autonomous error is always way larger than it looks in a controlled demo. You absolutely must enforce production guardrails, specifically the principle of least privilege, giving tools the absolute minimum access required. And for any irreversible write operation, like sending an email to a client or deleting a database row, you really need a human in the loop. Pausing an agent to wait for a human thumbs up isn't a limitation, it's just smart architecture.
You also need to keep a very tight leash on your tool catalog size. Giving an agent 50 tools doesn't actually make it smarter, it just creates a massive confusion surface. A model choosing from 5 highly specific, clearly scoped tools will consistently outperform one scanning through 50. Large catalogs just degrade selection accuracy, and they burn through your valuable reasoning tokens.
Okay, so if you only remember one thing from this explainer today, make it this one simple sentence. The AI proposes the action, and your deterministic code executes it.
Fundamentally understanding that strict separation of responsibilities is step 1 to building truly reliable AI systems. So take a close look at your own architecture today. Are your agent's tools truly functioning as clearly defined contracts?